Hello students, so we are doing probability. Okay, so next subtopic we are going to see is independent events. Okay, so let's learn through one example. Okay, so suppose I have to draw a card from the deck of 52 cards. Okay, so my event E is drawing a spade. Okay, card of spade, and event F is drawing a card of ace. Okay, ace card. So spade, how many are there? So probability of this event is spade are 13, so 13 by 52. Okay, and ace are 4, right? Okay, now the event which is in the intersection, that is a card is spade and also it is a ace. Okay, so probability of this event will be, so spade and ace, there will be only one card, right? 1 upon 52. Okay, now let's find out conditional probability, that is F event has already occurred and we are finding the probability of E event, that is the card is of ace. Okay, and we are finding probability of getting a spade. Okay, so it will be P of A intersection F upon P of F. Okay, P of A intersection F is 1 upon 52 and P of F is 4 upon 52. Okay, so this comes to 1 upon 4. Now if we look at this probability, that is P of E, that is drawing a spade, this is 1 by 4, right? So this is same as our conditional probability, that is P of E is same as P of F has already occurred, and then we are finding the probability of E. These two are same. Okay, so we can conclude that the event which is F, okay, has nothing to do with event E. Okay, so both events become independent events, means this, if we take them independently also we'll get the same probability. Okay, so F has nothing to do with E event. So this type of events are called independent events. And how to check this? So you have to use the multiplication rule of probability. Okay, that also comes from conditional probability, that is P of E intersection F upon P of F. Okay, so P of E intersection F is P of E or F into P of F, and we got here P of E is same as this. Okay, so if we get intersection probability like this, okay, then we can say that E and F are independent events. Okay, let's solve some problems. A die is thrown. Okay, E is the event, the number appearing is a multiple of 3. So number appearing is a multiple of 3. So how many are there? 3 and 6, right? And F be the event, number appearing is E1. So number is E1. So how many are there? 2, 4, 6, yeah, 2, 4, 6. Okay. Now you have to find whether E and F are independent or not. Okay. So what is the probability of E event? Sample space will contain 6 number of samples, right? Events, elements. So total number of outcomes is 6. So P of E is 2 by 6. Okay. P of F is 3 by 6. Okay. And we need P of E intersection F. So E intersection F event will be what? It has to be a multiple of 3 plus it has to be a even number. Okay. So multiple of 3 and even number, you can see here it is 6. Okay. So probability of this is 1 by 6. Okay. Now let's check for P of E. P of E into P of F. So it is 2 by 6 into 3 by 6. Okay. So it comes to 1 by 6. So we get this equal to P of E intersection F is equal to P of E into P of F. So we can say that E and F are independent events. Second example, 3 coins are tossed simultaneously. Consider the event E. E event is 3 heads or 3 tails. Okay. Then F, at least 2 heads. At least 2 heads. Okay. And there is one more event, that is G. So at most 2 heads. Okay. So let's write the elements. 3 heads or 3 tails, it will be H, 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 T, T, T. Okay. At least 2 means greater than or equal to 2. Okay. At least greater than or equal to. So 2 means T, H, 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 T, H, T, H, then H, H, H. Okay. Yeah, 4. Okay. Now we'll write G, that is at the most 2. Okay. So this will have at the most means less than or equal to. Okay. So at the most, write it down somewhere. Okay, less than or equal to. So less than means 1 also is there and 0 is also there. So without head it is TTT. Then take TTH, HTT, then THT, then HHT, then THH, then HTH. How many are there? 1, 2, 3, 4, 5, 6, 7. Right? Yeah. And sample space will contain here if I add HHH, then it becomes a sample space, right? So sample space will contain 8 elements total. Okay. Now let's find the probability of each one. So total we know 8 are there. So this is 2 by 8. P of F is 4 by 8. And P of G is 7 by 8. Right. Okay. Now they have asked of the pairs EF, EG and FG, which are independent, which are dependent. Okay, so you have to find E intersection F, then F intersection G and E intersection G. Okay, so E intersection F, how many are there? This one is there, only one. Okay, so 1 upon 8. Then F intersection G, these 3 are there, right? So 3 upon 8. Then G intersection E, TTT, so only 1 upon 8. Okay, now check for E intersection F. You have to check for P of E into P of F. Okay, so you can cut here 1 by 4, 1 by 2. Okay, so P of E right here. P of E into P of F comes to 1 by 4 into 1 by 2, so 1 by 8, which is same as P of A intersection F. Okay, so these two are independent events. Okay, then P of F into P of G. P of F is half into 7 by 8. So it comes to 7 by 16, which is not equal to P of F intersection G. So this become dependent events. Okay, then last one, P of G into P of E. So 7 by 8 into 1 by 4, 32, which is not equal to P of G intersection E. So G and E are not independent events, so they are dependent events. Okay, let's solve one problem from exercise 13.2. okay, 14th one. So probability of solving specific problem independently by A and B are half and 1 by 3. So P of A is half and P of B is 1 by 3. Okay, if both try to solve the problem independently, find the probability that the problem is solved. Okay, now they are solving the problem independently. Independently means the P of A intersection B be equal to P of A into P of B, right? So this will be half into 1 by 3, which is 1 by 6. Okay, so from this we get P of A intersection B. Now we have to find the problem is solved. Okay, the probability of problem is solved, that is either P of A person solves it or B person solves it, but problem should be solved. So it will be P of A union B. Okay, and you can use the formula for A union B, that is P of A plus P of B minus P of A intersection B. Okay, so P of A plus P of B minus P of A intersection B. So P of A is half, P of B is 1 by 3, and this is 1 by 6. Okay, so this will be making all the denominators same. 4 by 6, so it is 2 by 3. Okay, now let's solve the second part, that is exactly one of them solves the problem. Means one should solve the problem and second one should not. Now the second one is not solving the problem. What will be the probability? B is not solving the problem, so it will be 1 minus P of B, right? So both cases we have for A and for B also. So we need to find complement of both. So P of A complement will be 1 minus P of A and P of B complement will be 1 minus P of B. This is for A not solving the problem and this is for B not solving the problem. 1 minus half, so it comes to half. 1 minus 1 by 3, so 3 minus 1, 2 by 3. Okay, now let's find exactly one of them solves the problem. So P of A intersection B complement. Okay, exactly one is solving the problem. A is solving the problem and B is not solving the problem. So this will be P of A into P of B dash. So P of A is half, this is half, so it comes to 1 by 4. And P of A complement B will be, this is the second part, P of A to P of B. So this will be 1 by this is 2 by 3, right? So it comes to 1 by 3. And P of A into P of B is 1 by 3. So it comes to 1 by 6. Okay. So exactly one of them solves the problem. So you have to add these two probabilities. Okay. So it will be 1 by 3 plus 1 by 6. So it comes to 3 by 6. So half. This is the answer. You have to add this, so that you get exactly one of them solves the problem. We are taking both the possibilities. Okay.